for the second block we would be doing, this is the diagram, this is the drawing of the block. So now the first thing we need to do is identify the points, so that when we are doing the cut, we know we are moving from this point to this point to that point. So now the points, when you look at the cut, this cut, the points are always like at the middle section. So you must visualize the milling tool being on the block and how to cut. So like it's like a circle and it's cutting. So like this will be the center point, and then the mill will be like this. Alright, and then to move this way, move this way, move this way, and come back. So this will be our first point. Then we'll move to about here, and we'll move to about here, then we'll move to about here. So what we need basically is the x and y coordinates of this point, the x and y of this, the x and y of this, and then the x and y of this point. So now we look at the information that has been given to us in the question. Now we see that in the question it says that the length of this is 10, right? Let me see whether I can show it to you. Here it says that the length is 10. So like this side, this portion is this side. So like here is 10, here is 10. I mean the distance between the outer rectangle and the inner rectangle is 10. So that's how I've deduced that this side too would be 10. Now if here is 10, then we want about halfway of this point. That means that from here to here is about what? 5, right? From here to here is 5. Now the height of the length of the block is 100. And if here is 80, that means here is 10 and here is 10. So if we are moving from here, the base to this point here, in the y-axis, our y would be 15. Okay, so let me try and put it here. Our y here first, let me put this. As we know, the width is 200, so our x here, and our x here would be what? 200. Then our y, our max y would be 100. Then we'll put the center line, think about here. Now our center line would be 200, then should be 100, and then our y will be 50, just like the previous one. So here our y is 50. Now so you've discovered our y for that point. This point is 15. Now what is the x? Now we know that what do you call it? Here is 200 and here is 150. So here and here have a combined length of what? 50. So we divide it equally or by 2. Whereas that here and here will be 25. So if we come back to our graph, the x-axis of this would be 25, right? And then the x-axis of here would be 25, plus the 150, because we are moving 25 plus the 150, and we will get 175. So we've already discovered the points of the coordinates of these 2 points. So it will be 25, 15 for that point. Right? Then we have 175, 15. Now we need to find this point. As I said, here is 10. So here too is also what? 10. Sorry, let me clear the picture so you can see. So here is 10. Now we know here is 10. So, and then this length is 80. So here is 90. The top here is 90. But we want this point. We know that this is 5 because it's half of what? The 10. So when we calculate, we are moving from here. We move here to here is 10. Then here to here will be 40, because if here is 80, this will be 40. This length here will be 40, and then this length here too will be 40. Right? So here is 40. So we have 50. Then what I did was I added the other 40, which becomes 90. Right? 50 plus 40 becomes 90. Then I subtracted the 5 from the 90, which becomes 85, and that's how I got our y to be 85. To the graph line, our y here is 85, like that. So when we are finding this point, it will be 25 in the x and 85. Then the y, it will be 175 and 85, like that. So we have the 4 points. And as I said, we always imagine as if the the mill is on the diagram, so it's at the center point. Let me try and place a center on the mill, right? It's like this, at the center, like this. So the mill will be here. You see, the center is aligned with that. Then to go this way, come this way, come this way, like that. So it's the center. That's why when we look at the cut, we always look for the center of the cut, because it's the center of the mill. Now the cut is 10 millimeters wide. So in the question, the mill's diameter will always be set to 10 millimeters. Now maybe in case the question doesn't give you the mill's diameter, then you will have to know that looking at how wide my cut is, my mill's diameter has to also be 10. That's why our mill diameter would be 10. Yeah, so these are things you must take into account. So now that we have our points, let's go and do the CNC code. We start with the stock block code, which is stock backslash block. Then the width 200, the length 100, and the height. The x origin, for origin x is always 0, origin y is always 0. Then origin z is the height, which is 40. Now we shall be using G90, which is absolute referencing. G G21, which is millimeters, and then G95 is the feed rate code. It's a general setting. Then for our mil 2, the height 10, shall ignore the diameter is 10, we shall ignore the corner radius, which is 0, the height 15, and the taper angle is 0 as well. Then the color, let's use red this time, so 25500, like that. So first line of code, we tell the spindle to start spinning M03, and spindle speed, let's just set it as 1000. And the next line of code, G00, is to tell the tool to move 5. Let me run this so that the block appears. So here, this is our origin, as you can see. So we'll tell the tool to move 5 millimeters above the top of the block, which will be G00, to tell the code that we are moving, the machine that we are moving without cutting. So G00, then Z5. Now run it, and then we add the feed rates. With the first movement you do, you add the feed rate. Now feed rate is 80. So just type F80 like that. Now the next line of code will be telling the tool to go to where we are going to start the first cut. And our first point was what? X25, Y15. So still G00 because we are moving without cutting. We are above the block, so now we are moving to that point before we would come down inside the block. So G00, so we don't need to type what? G00 again. We just do X25, Y15. Now run, and you see that the 2 has appeared at that point. So next, we are at the point, we now tell the machine to cut inside. So G01, which means we are now cutting. G01 and then Z minus 20. Minus 20. And then the tool should cut into the machine like that. Now we're inside the machine, and now we can make the cut. So we move on to our next point. Now our next point is X175, Y15. They have the same Y coordinate, so we don't need to type X175, Y15. All we need to type is X175. And when we run it, it cuts across like that. Next, we are now moving upwards, and the coordinates for that point was X175, Y85. Once again, the X is the same, so you just come and delete it like that. So you just get Y85, and you run it, then it moves to Y85 whilst cutting. The next point is X25, Y175, Y85. Once again, you don't need to type the Y, so you just type X25, and then you run, and it cuts across. Then the last thing will be to come back to our first point, which is X25, Y15. The X are the same, so we don't type it, and we run, and it comes back. Now we fully completed the mill. Now pay attention, because we are moving whilst cutting the G01, we didn't need to type G01, G01, G01 like that. The next thing after we are done cutting is to tell the mill to raise the tool above the block. So G00, because we want it to move without cutting, and was Z5, and then the tool will be raised. If I move to the front view, see that the tool has now been raised above. The next thing we will tell the tool to do is go to the home. In this case, our home is X0, Y0. Then the tool moves to the home here. Then M06 is to stop spinning, and M30 is to end the program.